All right, chapter 2, number 4, problem number 40 reads the ball is thrown vertically upward with a speed of 19.6 meters per second. Part A asks us what are the ball's velocity and height after 1, 2, 3, and 4 seconds. And then B, draw the ball's velocity versus time graph. Give both axes an appropriate numerical scale. Okay, so we know that writing down the initial information, the initial speed of this ball is 19.6 meters per second. And then they would like us to go through and find out its position and speed at each of those time intervals. All right, so when time equals 1 second, let's do some work. We'll find that to find the speed, all we're doing is v sub f equals v sub o plus gt. So it's 19.6 plus negative 10 times 1. So v sub f is going to be equal to 9.6 meters per second. Then to find the position of it, or its height after that, we're going to do y is equal to y sub o plus v sub o y t plus 1/2 g t squared. 0 plus the initial speed was 19.6. It's been in the air for 1 second. So plus 1/2 negative 10 and then 1 squared. So when we do that, we find that the height after 1 second is 14.6 meters. Now if we do time equals 2, following the same process, 19.6 plus negative 10 now times 2, we find that the final speed is going to be negative 0.4 meters per second. And then again, y equals y sub o plus v sub o y plus v sub o t plus 1/2 gt squared. You get 0 plus 19.6 times 2 plus 1/2 negative 10 and now 2 squared. You get the height of the ball to be 19.2 meters above. What this is telling us here is that you'll see that the speed is negative 0.4, so it's started its way down. So somewhere between 9.6 meters per second and the negative 0.4 and somewhere between 14.6 and 19.2, it reached its peak. So the peak is just above this 19.2 meters. All right, so if we did the rest of this following the same exact process and just plugging in for the time, for when the time is equal to 3 seconds, we would find that it was traveling at a speed of negative 10.4 meters per second, and that its height would be 13.8 meters. And then for time is 4, we'd find the final speed to be negative 20.4 meters per second, and then its final height would be negative 1.6 meters, which means it's now below where it was thrown. So that could be it. If it's a tall person, it could be below where they released it from. Maybe it went off of a cliff and fell below them after that. A bunch of different reasons that it could come up with. So that was part A. Part B now wants us to graph the velocity time graph for these speeds. Right, so if I draw a graph real quick and I get, let's do that. And do this. Right, and we know we have a velocity time graph, so it's really going to be Vy and T. And we're going through a couple different points, so we'll set the scale to be right here. So that's 20, and this is 10, and then this is negative 10 and negative 20, and we're looking at a 4-second time period. So let's give ourselves a four dash marks. 1, 2, 3, 4. If we do that, and then we plot those points at 0, time is 0, we get the speed to be 19.6. When time is 1, the speed's about 9.6. Time is 2, the speed is 0.4, so we'll do something like that. 3, when time is 3, it is negative 10.4, so it's just a little below that 10. And then for the last one, for time is 4, it's about negative 20.4, so it's somewhere right around there. So then if we drew our nice little line of fit to give us an idea of what it looks like, we can draw something that looks kind of like that. So that would be what our graph would look like there. So that is problem number 40 from chapter 2.